Hi, I'm Derek Calloway from Dewhurst Airfield Services in the UK. We're an AGL installer and representative of S4GA. We have a lot of experience with the medium intensity lighting, and I'm here today to ask Łukasz Kornacki some questions about the new Category 1 airfield lighting.
I hope I can help.
I think the first question that I've got, which most people will ask, is about the compliance with ICAO Annex 14 and the range of light fittings you've got. I take it that all the light fittings that you offered will be compliant and certified to ICAO Annex 14?
In short, yes, all the light fittings that S4GA manufactures, is it high intensity, medium or low intensity, they are always in compliance with the number of regulations. ICAO Annex 14, of course, is the major one, but apart from this, also we take into account multiple others like FAA, like CASA, like EASA regulations, even the British CAP. So it's not only ICAO and
Yes. I mean, from the UK, it's CAT 168 compliance we'd be looking for. But I think that'll be the first question people ask, is it compliant? So that's great to hear. So with the light output for the Category 1 runway edge fitting, it's approximately 10 times more than what the SP401 provides in candela output. Does that reflect a sort of 10%, the same sort of ratio reduction in operating time at maximum brilliancy?
That's a good question. The actual answer is no. And the reason is optimization of the optical design. So even though you would think that, let's say 10 times, roughly speaking, 10 times higher brilliancy would mean 10 times higher power consumption. In case of S4GA, CAT 1 Solar AGL, it's not the case. As we have been, let's say, we put a great delta of time and effort to optimize our optics to be as efficient as possible. And we actually reached quite an astonishing number of 97% efficiency, which in fact translates into an extremely low power consumption. If you compare to any other actually fitting in, is it solar or is it non-solar, the efficiency of the optics is very high. Therefore, actually the power consumption is low. So when you compare it to our medium intensity products, the actual expected ratio would be rather closer to 6 or 7. So in order to get 10 times more brilliancy, you will have, let's say, 6 times, not 10 times higher power consumption. That will result with much higher operating time because of that.
So on that basis, in the Northern Hemisphere, I mean, historically our projects, you've done a solar feasibility based on hours of operation required, location of the airfield. I take it you'll still be doing that sort of thing for the Category 1, but it becomes a bit more prevalent, really.
The answer here is, you already gave the answer, yes. We will do the feasibility study because that's a standard that S4G is following, and this standard is recently being introduced as well on the SALA level. So feasibility is a must. And is it a low, medium or high intensity? We believe that making a proper calculation of the actual feasibility of the solar system for particular airport is an absolute must for any airport before taking any decision. And that's going to be the same for CAT 1.
When we're doing that feasibility study, we get the data from the airfield, what operational hours they want and everything. Invariably, they're looking at maybe short-term forecasts or current forecasts. I think every airfield will want to improve the operations and get more business in. So is the system scalable?
System is very much scalable. So in case you can imagine an airport today, let's say, operates roughly, they want to secure, let's imagine 5 hours daily on CAT 1 conditions, right? And then imagine that 5-10 years down the road, they would increase, let's say, to secure level of 10 hours. So they first install a system that covers the 5 hours with a proper buffer. But in reality, if they would like to increase it, for them it's very simple. They just add additional equipment, which will be additional solar engine. So the
light fitting stays the same?
The light fitting stays the same. All the installation stays the same. What we really talk about is maybe one more additional equipment standing basically next to the existing solar engine.
Okay.
That would double the operating time.
Yes, yeah. So the architecture is going to be different to the SP401
Yes.
in the fact that that's got its solar panel next to it. This will have a separate solar engine
That's
positioned
correct.
away from the light.
That's the major shift from the design where you have everything in a self-contained light.
Yeah.
For various reasons, it's not possible anymore with the CAT I product.
You need a bigger solar panel.
You need a bigger solar
for that
panel in
extra
order to have enough charging and have bigger battery. You cannot put it on the runway. You need to shift it away. So basically you have the fixture, then you have a short cable wire that will go from the solar engine with the DC power. And then the solar engine would be the unit containing all the electronics, all the batteries, all the solar panels.
Yeah.
Everything will be basically in the solar engine.
So that solar engine, I take it that's sort of below 900 mil high.
Of course.
And that would have to be positioned probably behind the stop bar positions, which for CAT I in the UK, I think it's 90 metres from the runway centre line. So effectively you could have a 70 metre, up to a 70 metre distance.
It's not an
from
issue.
The light fitting.
The expected length of the cable can be up to 100 meters per light. That's not really an issue, technically speaking.
Yeah.
And you mentioned rightfully that we would like to go out from the CAT I zone, because actually this also means much easier maintenance access.
Yes.
So for various reasons, this is probably the best option. Imagine for an airport, but it's not a must. If the airport would wish to keep it inside the zone, all the solar engines are frangible and designed to below 90, so 900 mils, so 90 centimeters. So they will also meet the standard of frangible items within the CAT I.
Within the strip.
Within the strip. Yeah.
But like you say, I think ideally you'd move it.
Ideally, we would recommend to move it.
And then maintenance staff can get access. Without affecting flight operations because they're working behind the stop bar position. Solar engine per runway edge light, and equally for an inset threshold or elevated threshold, it'd be one solar engine.
In general, let's generalize this question. In general, yes, one solar engine, small but suitable for the operations of the high intensity light, is 1 per 1. Now, in certain instances, when you would say a group of lights, let's say a threshold light, you could actually think of just having a bigger solar engine installed and then covering 2 or 3 or 4 lights at the same time. But because they are all close together, this doesn't make much sense when we are thinking about having the same concept with one bigger solar engine, let's say powering 3 or 4 runway edge light, because then the distances are increasing exponentially, and then the cabling becomes too complex and too actually long. So the, let's say, the grouping of the lights when they are together, we can have a bigger solar engine.
Yeah. Okay. So looking at, say, a CAT I approach now, you would have your light fittings on the masts. One of the issues predominantly with the first LED fixtures that came out on the market was the weight of these light fittings. But you're saying it's just going to be the light head at the top, and then all the solar engine and control will be lower down at the base of the mast?
Yeah, due to the design that we came up with, is that basically there's no electronics inside the light.
No.
It's pretty much the fixture, the LEDs, the radiator that dissipates the heat. And then everything else is in the solar engine. So the solar engine is connected to the light with basically a cable. It does have in the cable also a, let's call it communications cable to a simple sensors like temperature, humidity, etc., because you still want to monitor the performance of the light, but there's no power drivers in it. So therefore, actually, the entire fixture weight or size is very much alike to what any other manufacturer
Similar
today.
to what the halogen lights used to be like.
I would say exactly. There's no specific extra weight there because of the solar concept, because everything, there's no batteries in the light as well, of course. Everything is in the solar engine, which is in case of approach lights on the ground.
So on the CAT I approach again, you've got your solar engine at the bottom. Can that one solar engine feed the 3 lights on a pole?
Yeah, so that's the case I was just
or,
describing with the threshold, and for an approach light, you would have a bigger solar engine that can cover the power consumption of 3 or 4 approach lights even, and there will be a cable running from the bottom of the pole up to a centralized unit that then would distribute the cabling to individual lights.
Okay. So just popping into my head again now with the approach lights, you're going to have this solar engine at the base of approach light. In the UK, a lot of the approach lights are out in farmers' land, outside of the airport strip. So there's always a chance that things are going to go missing, getting stolen and things. But when you're talking then about the sensors in the lights, that will detect if anything happens straight away, won't it, and report back to your control system?
I would say even more, because you said only about the sensors in the lights, like movement sensor is also a tilt sensor built into the light, but we also have sensors in the solar engines, including movement sensors.
Okay.
So in fact, this necessity comes from not only the specifics of the UK, but a lot of places in the world where things go missing.
Yeah.
And then you can imagine that you have unauthorized actions on the solar engine.
Yeah.
And then because there is a movement sensor, the operator can, within a real time, get the information.
Yeah.
So something is going on with the solar engine, please react. And therefore, this information can be instantaneous.
Yes.
With the technical teams, they can react. So yeah.
So that's good. It's a good feature. Going back to the light fittings themselves and the installation, close to my heart, the installation and what's involved there. Do you have sighting devices for, say, a runway edge fitting, and then if you had a unidirectional approach or threshold runway end?
Naturally, it's a good question. Here we are pretty much in line to what the industry standards is like.
Yeah.
We have the sighting device, we have the leveling device. Is it for a runway edge, or is it for the approach light, or a runway threshold unidirectional lights? We provide the complete set of devices that you would mount on the light and do a proper calibration of the light when on site. On top, you can also level the light when you have uneven ground or uneven concrete and the base is not leveled. You can actually level the light properly. So here there is no, I would say, nothing unusual to what any other manufacturer of AGL would do.
Yes.
And we just follow the standards.
And going on from that, you've got the maintenance as well. So on a normal, typical system, you've got to go and clean, you've got to check the alignments. So that would be the same for your fittings.
That would be the same. Mm-hmm.
Is there any additional maintenance that we need to look at?
I think the most obvious additional maintenance for solar systems is that the solar panels would require cleaning.
Yeah.
Now, people ask me often, how often would you need to clean? And the answer is very simple. Let's say there is different levels of dirt you can expect to have on your solar panel. And this dirt accumulation also will differ from country to country. If you are talking about Middle East, the accumulation will be much faster than it is for sure in the UK.
Yeah.
But always the question is, but when do we go clean it? And the answer is very simple in terms of S4GA CAT I system, is that the actual ALCMS, and there we have the preventive maintenance section in it, will tell you when to go.
Yeah.
Because a little amount of dirt on the solar panel doesn't mean immediately that you need to go and clean it, because a thin layer of dirt will not immediately stop charging.
No.
So what you want to know is when exactly to go, is when your charging is affected to the point of the threshold that was set. And the system can detect it and report it, and basically say to the technician, listen, this specific solar engine standing in this location is no longer charging to the efficiency that we would be expecting. Go and clean it. That's as simple as that.
Yeah. And on battery changes, on the 401Ss, I think we're sort of promoting in the UK, change your batteries every 2 to 3 years.
Yeah.
Is that going to be similar for the solar engines?
Now, we are looking at different generations of batteries. Let's say what you just mentioned is pretty much the most standardized type of battery which we supply, which is the lead acid, right?
Yeah.
But of course, already another types of chemistry is available, even with the existing portfolio, which is the lithium-ion LiFePO4, and now the newest battery that we are actually heavily looking into, and we are thinking this could be a very great let's say, add-on to the CAT I family. It's a sodium-ion batteries, which have all the, let's call it, advantages of an ion or lithium technology, which is the higher density, much more cycles, etc. But with the temperature resistance that would be suitable for, let's call it, moderate latitudes, where the temperatures sometimes drop below zero.
Yes.
And which most of the lithium-ion batteries cannot handle. Yeah. But actually, sodium-ion is the battery to look into. Right. And S4GA is heavily investing in this technology today.
Right. Okay. Just going back to the maintenance and the cleaning of the solar panels, the SP401s on the control system, and it's something we've sort of highlighted to our clients, is to check the solar efficiency, because sometimes it may show a uniform 30% and then 2 or 3 fittings down to like 5%, which we've always said, right, that indicates that something's maybe it's been disorientated or it's dirty,
overgrown as well. Yeah.
That'll be exactly the same for the Category 1 lighting system.
Of course. So at the end, we are talking about, as you mentioned rightfully, already with our medium intensity systems, we do have the preventive maintenance section in our ALCMS that is mostly used not by the tower but by the technicians, right? Yeah. And this is only with the AI development, with the intelligence of the system reporting or predicting potential issues. This is only getting better and better. So the new ALCMS system that goes together with the new CAT I systems that we are planning to deliver will be, let's say, another level, another layer of advice or kind of solution.
The more feedback and the more information the maintenance guys have got.
And even less kind of browsing through the amount of data that you have.
And again, on the maintenance, there's no need for any primary cable maintenance, is there? And transformer testing, and
there's
you know, so it's got the advantages there as well. So looking at a typical AGL system now, a 6.6 amp wired system, runway edge and interleaving of those, often fed from 2 different substations. The architecture that you have is not providing power to the light fittings, but it's providing communication. So is there sort of an interleaved, how does that work? So if you lost the communication link?
In the solar systems, you distinguish, let's say, 2 topics. One is the power and the other is the communication. Now, these are combined in a typical 6.6 constant current systems. In one cable, you have both. You have the communication, meaning the step of the current, what gives you the brilliancy level. So let's call it communication for the simplicity of the discussion. And then you have the actual power, right, that goes into this cable. So there's one cable serving 2 purposes. In solar systems, they are detached. These topics are detached. So one thing you asked me about interleaving concept, how is it applied in the typical solar system?
I'm just thinking this is what people are used to.
And that's what they're...
So it's a question.
Actually, this is a very good question because it goes into ADM mindset of the ADM and document 9157, which is the redundancy of the power supply. So solar engines are designed in, let's imagine the solar engine is a 1 unit, but actually it's 2 units inside. So then you have 2 batteries inside. They are independent, they work independently, and they power the light independently. So that's how we manage the redundancy on the power supply. Actually, the solar engine is not having 1 solar panel, it's actually 2. And each one is powering, let's call it, half of its electronics and half of its battery capacity. So that's how we get to the redundancy level. Now, but on top of it, we need to be redundant on the radio communication, because that's how we achieve our communication with the unit and control of the unit. So in fact, each solar engine has 2 independent radio modules and 2 independent antennas. And then this setup guarantees absolute redundancy on both power and communication and control.
And if, for example, there was an air traffic fire and the system and the control unit, the primary controller, is perished, are you able to have like a standby system
Yeah, well, again, we have to
Standby
follow
HMI.
the regulations which are already there. So in control, the concept of the controls, you will have on the airport, you will have the main controller in the tower, and you will have typically a backup somewhere in the airport, typically within the workshop. And yes, and you can take over control and you can control the system from the workshop.
Okay.
In S4GA systems or solar systems as such, you actually can go further. You can use a handheld controller.
Yes.
And you on the last resort, you actually can use one of the lights as kind of a controller, and then you have an emergency switch where actually switching on one light would illuminate all the lights on the runway, which is the concept that the 6.6 amp doesn't have at all.
No,
right?
No. And historically, I know it's been an improvement on the medium intensity lighting, that the emergency button on the fitting turned everything on at 100%. Obviously for category 1, you know, at night time you do not want 100%.
Sure.
So the new buttons, you can select the brilliancy.
Yeah,
and that
you can actually, using basically this one button, you can select the brilliancy.
Yes.
And the brilliancy, which is 5 steps, will be applied.
Yes, yeah. So going back to the control system, in the UK, a new control system is subject to a 4-part safety case, which drills down to mean time between failures of components and things like that. I know that we've supported a safety case for RAF Leeming in the UK. I take it you'll just be doing the same thing. So it'll be an outsourced safety case, but you'll provide all the technical information and data.
Exactly the same way we did it already with the existing systems installed in the UK. This is, by the way, for the CAT I, we're going to have a completely new design of the control unit, which is already basically in progress. And then we will use the rack design, which is even closer to the existing systems, how they are built today. But at the end, we are just, as a manufacturer, we're the source of the information for the safety case. And having in mind the experience that we have and successful systems already installed in UK and worldwide, I'm not too much worried about the structure of this information and the systems that we are building in the context of requirements.
So aside from all the technical and installation issues and the layouts and things, obviously one of the big questions customers are going to have is the cost. I suppose it's very difficult now because each airfield will be different. If it was a greenfield airfield, completely new system, do you think it would be cost comparative for the solar CAT I to a wired system based on less trenching,
it's a good question.
Infrastructure?
If I just set the scene, if we are speaking about complete cost, which in my head is capex, installation, yes, then opex, and then the maintenance, and if you take the whole package, which if what I have seen, that's how the consultant companies, which are evaluating a system, actually they even look at about 10-year period or 20-year period. Then the advantages of solar are like enormous. I'm going to say hammering the wired systems. If you want to just compare fitting to a fitting, then S4GA or any other is going to be more expensive. But if you compare the real long-term project value or cost, then any wired system doesn't stand a chance.
And I guess the installation time and disruption to airfields as well is going to be a lot less.
There is also cost in this, which is almost never calculated. How much does it cost to have a disruption of the wired system and then diversion of 2 or 3 or 5 or 10 planes within an hour? I wonder whether this ever is taken into account by anybody when making a calculation. Whereas in the solar system, you flip a switch, even if you have a major, let's say, power failure and the tower goes down, that you actually can still press a button and have the plane to land. That would say, in some cases, we did the studies in the past, it's just one wide body plane was, in terms of revenue, the hotels for the customers, diversion to another airport. All this, when you take into account, the cost was not far, let's say, less than basically having a solar system standing by on an airport and waiting for waiting for a potential failure of the wired system.
Yes.
And
yes.
we already have customers worldwide having these thoughts materialize to actually install today our medium intensity systems as a backup systems to the wired system.
Yes,
yeah?
yes. And the transition, if there's an airfield there now with a fixed wired system, the transition is very simple. You go and install this solar system in parallel. You can fully test it before changing over onto this system.
We would even recommend if the customer, let's say, have a legacy system that is, let's say, 20, 30 years old, and it's slowly dying, and they are considering, they would go for solar, I would tell them, hey, leave your wired system in place, install the new solar system.
Yeah, yeah.
As the complexity of installing a solar system, even CAT I permanent system from S4GA, is significantly less.
Yes.
You don't have to duct, you don't have to run kilometers of cables. So it's like, it's super, super simple.
So looking at the integration of solar, where there's already a AGL wired system at the moment, I take it you can do it gradually. So you could maybe just do an approach on the solar and integrate that into the existing control system while still having a wired runway edge threshold end system.
And in short, the answer is yes. That absolutely is plausible. We can do it. We actually already are doing it sometimes with our medium intensity systems or low intensity systems.
Yeah.
So in the same way, actually, it will be possible with the CAT I system.
Okay.
How would that work? Is that we would, let's say, replace the hardware on the approach side. Yeah. Put the solar engines and the approach lights powered by those solar engines, and they would be controlled by the existing control system, CMS, ALCMS, whatever is installed on the airport.
Yeah.
And there would be, of course, an interface part, but this interface is something that S4GA would supply.
Yeah.
And let's imagine a box that receives the signals from an existing system and translates those signals to radio communication that goes directly to the approach lights, and they act exactly the same way as they would be connected via a series circuit, but they are not.
Yeah.
But in fact, even the CMS receives a feedback like it would be dealing with the CCR communication.
Yes, yeah. And again, from an installer's point of view, there may be an existing approach with the wired lights on and they want to reuse the existing masts. So we would have to carefully work out getting all the solar panels, getting the light fittings maybe mounted adjacent to the existing, and then doing a changeover from one system to the other. But that's for an integrator.
It would be technically possible because you have to have in mind the weight of, let's say, dual optical heads. I'm not sure if that would always be possible.
No.
But here, it will be probably case by case.
Yeah, but again, you can do a phased handover. So
phased handover
bars,
is
first crossbar, second
possible.
crossbar, and then move on. And you were talking about, when we were talking about costs as well, about the maintenance being part of the capex. I don't think it is, but I think it's often it's overlooked really, because you've got to have your HV authorised persons, you've got to have the training kept up to date. So I think you won't need any of this HV training for this.
I would say like this, because many people are afraid of this argument. Oh, but we will not need those HV electricians.
So
those HV electricians are starting to worry. What about us? Yeah, are we going to be not necessary anymore? And I'm thinking in the terms, have you thought about it that, by the way, there's plenty still of other systems in the airport that you can manage, but this one would be much easier for you to manage, much less stress, much less hassle, safer.
Yeah.
And that doesn't mean that you won't be necessary. I'm pretty sure that there are other topics that you will be able to focus on by having this extra time. And manage them better, basically, because today you won't have the time because you're dedicated to the wired 6.6 amp systems. So this argument of people not being necessary, I would say.
But as an accountable manager of an airfield, safety lies with you, and this is a great option really to reduce harm and risk.
Yes, and we see that worldwide there is the harm that happens. Yeah. It's very rarely reported. We see it usually being told behind the closed doors about the accidents that happen let's say, in different circumstances.
Yeah, no, that's great. No, thanks for your time.
Thank you.
Thank you
Thank you for the interview.